So these are the fundamental units. Now we are taking these fundamental units for deriving the other units, means in formulas we are using. So those formula units are called derived units. Now take the derived units. I have written here quantity, which symbol we are using for that one, and what are the units. Linear velocity or velocity. Using V symbol. Velocity means how much distance it is traveling per time. Distance by time. Units are for distance I am taking meters. For time I am taking seconds. Similarly, linear acceleration. Change in velocity with time. Okay. So it is A symbol we are using. Now here velocity by time. Okay. Velocity symbol is meter per second. Per second means meter per second square. Okay. Velocity by time. Velocity means meter per second. Per second means meter per second square. Third one is for angular velocity, we are taking the symbol omega, means how much angle it is moving, angular per second. Means for angle we are taking radians per second. Means vehicle is moving how much angle per second. Okay, per second. So it is called radians per second. For linear velocity we are taking meter per second. For angle we are taking radians per second. Similarly, fourth one, angular acceleration. We are taking the symbol alpha. Here also for linear acceleration we are taking v by t. T means time. For here we are taking w by t, means radians per second means radians per second square. Okay. So for fifth one I am taking mass density. Which symbol we are using for density? Rho. Taking mass by volume. Okay. For mass, what are the units? Kgs. For volume, we are taking meter cube. Okay. So this is called mass density. And force. Capital F we are using. What are the units for force? Newtons. Here I am taking pressure, means we are using the symbol P. How much force is acting per unit area? Okay. It is called F by A. So force by area. What are the units for force? Newtons by area means meter square. Okay. Work means because of this some force. Okay. Because of some force, one object is moving from this point to this point. Some s distance it is traveling. Some length it is traveling. Means force into distance. How much distance it is traveling. Now for work I am giving the symbol capital W, or we can call it as energy also. For energy, we are giving the symbol capital E. Okay, work or energy. So here I am taking work means force into distance. Newton into meter. Newton, meter, or for energy, joules. We are taking joules. Okay, and then next one is power. Power means rate of work or rate of energy. How much work has done per time, per second. Okay, we are using the symbol for power capital P. Now here I am telling W by T. Rate of work means rate means divided by time. Okay, so here the units are Newton meter by second or joule by second. Watts. Okay, so joule per second means watts. Okay. Next quantity is frequency. Frequency we are using in waves, in measuring waves or vibrations like that. Which symbol we are using? Small f. Now the units are H. Okay, these are the other these units, watts. Here frequency means H, capital H, small z. Okay, so many waves per cycle means cycles per second. It is called 1 Hz. Okay, so how many waves are there per second, like that. Okay, it is called frequency. Now last one is specific heat. Specific heat means how much heat is required for 1 kg of mass for increasing the temperature 1 degree. Okay, let us assume the temperature of the object is or liquid is 10 degrees. Now we need to add one more degree to it, 11 degrees. Okay, how much heat is required for heating that liquid in up to 11 degrees, means 1 degree. It is 10 degrees. We have to increase in 1 degree. We are using the small c. Now units are joules per kg Kelvin. I will explain this in next classes, how we are getting this one. Now one more thing, one more is here, molar mass or molecular mass. Molecular mass, we are using symbol M. We are using this for gases instead of air, kg per mole. Okay, these are the some of the important units, derived units from the fundamental units.